A lot of people are complaining about this homework, so I thought I would go through and do it. Um, so for this one, it's a little bit of an art, to go back to the function and the definite integral and things. I've got a little notepad here, but I wish I could look at both the web page and at my little notepad at the same time. So maybe I can do that. So we have this Riemann sum here, the integral from 0 to b of f of x dx, and so this is equal to the limit as n goes to infinity of the sum as I goes from, it says that it's a Riemann sum that is a right-hand sum for me, so that means it goes from 1 to n. It's randomized, so you might have a left-hand sum possibly. In that case, it would go from 0 to n minus 1. And here we have f of xi times delta x. Okay, so let's just look at what's written here. It looks like it's very likely that 2 over n is delta x, because that's a factor that everything has in common, and you know that delta x is equal to b minus a over n, and so this seems to be equal to 2 over n. And we know from the little integral that they give us that a is equal to 0, so this means that b over n is equal to 2 over n, which means that b must be equal to 2. So that helps. That's the first part of the question here. B is equal to 2. And let's go on to the next part. So we have to find the function f. So one thing we can do is we can look at x1. So x1 is a plus delta x, just by definition. And because this is supposed to be a right-hand sum, it's not logically necessary, but it's very likely that this first one here is f of x1. So we know what x1 is because b is equal to 2, and we know what delta x is and what a is. So this is just saying that we're looking at f of 0 plus 2 over n, which is f of 2 over n. And now let's try to sort of make sense of f of 2 over n in terms of just this first thing in the list. So somehow f of 2 over n is going to be equal to the square root of 4 minus 2 over n squared. Okay, and I'm ignoring this 2n factor because we already said that was delta x. So it looks very likely that what's going on here is f of x is the function square root of 4 minus x squared. And you can just do a sanity check here. So if delta x is 2 over n, then this will, what should x2 should be equal to 2 over n plus 2 over n, which is 4 over n. Yeah, so I'm convinced, and let's type it in and see. So it's the square root of 4 minus x squared. All right, so let's check that. Yes, I am dynamite. Let's do the next one. All right. So this is a sum of cubes, and you know the sum of cubes formula is the same as the sum of the first consecutive numbers but squared. So the sum of, let me just start at I equals 1 to n of I cubed. I guess I should be using k because k is the counter here. So let's use k. So the sum of the first k cubes is equal to n times n plus 1 over 2, but everything in sight is squared. So n squared, n plus 1 squared, 2 squared, etc. So look at this. Here we start at 100 instead of starting at 0. So the key insight here is that the sum as k goes from 100 up to 250, in my case, of k cubed, is the same as the sum as k goes from 1 up to 250 of k cubed minus the first ones, which we don't want. The ones that we don't want are the ones from k equals 1 to 99 of k cubed. So this first, just use the formula both times, so you have 250 squared times 251 squared divided by 4. Take away, I guess the whole thing is going to be over 4, isn't it? So I could sort of save myself a little work here. Minus 99 squared times 100 squared. And that's the answer, whatever that is. I'm not going to bother to type it in there. So let's go to the next one. You can tell that pains me, can't you? Evaluate this limit. Sure. So let me scroll down a little bit. And how do you make another page here? Give me more pages like this. All right. So we have to do this limit, and we can take out everything that doesn't have anything to do with j. So I'm just going to go ahead and factor that stuff out. So we've got the limit as n goes to infinity. N can come out of the sum, and so can the 7. So you get 7 over n cubed times the sum as j goes from 1 to n of j squared. Oh no, this is the hard formula. So we use the formula for the sum of the first cubes, or sorry, squares, and get rid of the big sigma. So this gives 7 over n cubed. And what is this formula? Good Lord. I might be getting it wrong. Oops. But I believe it's n times n plus 1 times 2n plus 1 over 6. All right. So now I'm going to use this trick, which is that you have a cubic polynomial in n on top, a cubic polynomial in n on the bottom. The leading coefficient on the top, if you multiplied all this stuff out, would be 14, and the coefficient on the bottom is 6. So you've got the limit of 14 times n cubed plus lower degree stuff, who cares. And on the bottom you've got 6n cubed plus a bunch of, actually there's nothing there in that case, it's just 6n cubed. And so there's a well-known fact, which is that if you have a situation like this, the limit is just the ratio of the leading terms. So it's 14 over 6, which is 7 over 3. And let's check that out. Yes. Next problem. Consider the function blah blah blah. In this problem you will calculate blah 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 by using the definition blah blah blah. The summation inside the brackets is the right-hand Riemann sum, where the sample outputs are chosen to be the right-hand endpoints of each subinterval. Calculate Rn for this function on the interval 0 to 4 and write your answer as a function of n without any summation signs. All right, so first you come up with the expression, and then you cry because you don't know what's going on. These problems are pretty hard. Let's see. Oops. I'm going to try to split the window like that. All right, so the first thing I like to do in these problems is to figure out delta x. Delta x is b minus a over n, which is in this case 4 minus 0 over n. Which is 4 over n. And I know that a is 0 and b is 4 because I'm looking at these numbers on the little integral stick. The top one is b, the bottom one is a. And what else do I need to do? I need to figure out what xi is. So I've got, this is a right-hand rule, so like we said earlier, we're going to start with x1, which is a plus delta x, is what it always is. And a is 0, mercifully. And delta x is 4 over n. So x1 is 4 over n, and I'm just going to figure out x2 also and kind of get a feel for what these things are. So this one is going to be delta x plus the previous one, so that'll be 8n, and then x3 will be that plus another delta x, which will be 12n. And now I kind of guess the relationship that's happening here. It's just like there's a little index here in each case, and the number on top is just 4 times that number. Observe how that's true. So that means that the ith one will be equal to 4 times I over n. Wonderbar. And can use this little tool. Oh, that's the wrong tool. Oh, this thing only shoves stuff down. Oh, I don't want it to go down. Man. So let's go up a little bit. Do you really have to divide it into different pages? So silly. Can I go back to the other page, please? Now what's going on? Oh, good lord. Okay. Oh, it took me all the way back to page 1. Here's where we were. Wonderful. Acceptable. Anyway. So there's xi, and we need f of xi, and we know that f is this silly function. So f of xi is going to be 4i over n plugged into negative x squared over 2 minus 5. So that is minus 16 I squared over n squared. That was the square. And there's the 2 down here. And minus 5. Okay. Great. Now we need to figure out the sum of the xi, right? What is it we need? We need the sum of f of xi times delta x, just by the definition of the Riemann sum. And I goes from 1 to n. So what we have here is the sum as I goes from 1 to n of 16 I squared over 2n squared. And I can just put a minus sign outside. Both of those are negative. So I'll take care of that just by putting the minus sign there. And then that will give me a plus 5. And all of this is times delta x, which is 4 over n. Okay, so let's manipulate this thing. What we need to do really is just clean it up, take out everything that doesn't have anything to do with I. Can I do this? Oh, oops. And move it up here and delete this little thing. All right. So this is equal to, let's start taking it apart. One thing I could do is just take that 4n outside immediately. And I can also split the sum into one part that has 16i squared over 2n squared, and another part that is just 5, 5, 5, 5, 5. And the counter for both of these goes from 1 up to n. Okay, and this one on the right here is very dumb. This just adds up to 5 times n, because it's just 5 added to itself n times. And for this other one, you can factor out, you know, the 16 and the 2 are going to cancel and make 8. And you've got I squared on the bottom and n squared on the, sorry, you've got I squared on the top and n squared on the bottom. So let's flip that around a little bit. Now we've got minus 4 over n. And inside the brackets, what's left to come out? An 8 can come out, and an n squared on the bottom. And we've got the sum of I squareds. Man, I hate that formula. I equals 1 to n plus 5n is already done over here. So this sum is not part of that 5n thing. Okay, so we're getting somewhere now. And we've got minus 4 over n, and inside the brackets 8 over n squared times, here's the formula, I believe, n times n plus 1 times 2n plus 1. Didn't we? Yeah, we checked the answer for the previous problem and it was right, so this is the right formula. Plus 5n. Okay. And I'm going to copy this thing. And take it over to the next page. And erase this little stowaway. Okay. So, we've got the answer to the first part here. That is Rn. But we can simplify it. So let's multiply n this negative 4 over n. I get negative 32 over n cubed. And I've still got n times n plus 1, 2n plus 1 over 6. Alright, so this is good. I've got a cube on the bottom, a cube on the top. And also, when negative 4n comes over here, those n's cancel each other, so that's a positive sign. And I get negative 20, which involves a negative sign in quite another sense. Okay, so I can cancel a factor of 2 between these two things. Yeah. So now let me do that trick on this thing. Oh, my toddler is coming. Oh gosh. Oh no, she's very interested in this. I'm gonna have to pause the video. Oh, my wife is taking her away. Oh, it was like that CNN scandal without the visual component. So on top I've got negative 64 times n cubed plus a bunch of who cares, some lower degree stuff. And on the bottom I've got 6n cubed, and out here I've got minus 20. Alright, so now for the second part we need to take the limit as n goes to infinity. So the limit as n goes to infinity of the stuff above there is equal to just the ratio of these leading coefficients. So that's negative 64 over 6 minus 20. So if that number is correct, then the answer for the other part must be correct also, and that's a lot more typing, so I'm just going to check this one. Minus 64 over 6 minus 20. Yes. So if I bothered to type in the other part, that would have to be right too, and you can just type it in yourself. Okay. Your task is to estimate how far an object traveled during the time interval from 0 to 8 seconds, or from 0 to 8, yeah, it's seconds. But you only have the following data about the velocity of the object. Here's 1, 2, 3, 4, 5, 6, 7, 8. Alright, so conveniently, there are 8 rectangles, one for each second. And there's the velocity function, and we've got the Riemann sum that comes from looking at the left endpoints. You decide to use the left end, whatever this thing says. Total displacement and total distance traveled. So the total displacement is the net area. So we can just add these things up. There's a little scale here, isn't there? Yeah, so it's just units of 1. So each rectangle has a certain area. Each of them have width 1, which is very convenient. This first one is 1, 2, 3, 4 units plus 3 units plus 1 unit. I'm just reading them off. Plus 3 plus 4 plus 1. And then down below the x-axis here, there's a couple negative ones. There's a negative 3 and a negative 1. Okay. So if I add all these things up, then I get the total displacement. So what does that amount to? I can just sort of, this 3 cancels with that, and this 1 cancels with that, and add up the rest. You get 7, 8, 12. So that is 12. This is the total displacement, which I would prefer to call the net displacement. And if you want the, what's the other thing that it wants? It wants the total distance traveled. So that's the integral of the absolute value. So that means you count all those rectangles positively. So that would be 12 plus this extra 4 down here, which would be 16. So distance traveled is equal to the 12 that we, no, wait, sorry, I'm being dumb. This is not right. We need to just add them all up positively. 7, 8, 11, 15, 16, 19, 20. So this one should be 12, and this one should be 20. And using the same data, you also decide to estimate how far the object traveled using a right endpoint Riemann sum. Oh God, spare me. You can do that yourself. And so let's check our answers. Your answer doesn't look like a number with units. Oh no. Be sure to use proper units. So does that mean that I need to say feet? Let's try that. Okay, now it's right. The interval from 0 to 5 is partitioned into n equal subintervals, and a number xi is arbitrarily chosen and the ith subinterval for each. Then the limit of, they should call, okay, xi is supposed to be arbitrary now. Usually you put a star on it when you want that to be true. And you want to add all these things up. So it is very easy. You do the limit. How did this pen turn blue? As n goes to infinity of, now the 1 over n can come out, and what you get left with is 6xi. I just noticed there's a little extra thing going on here. So let's look at the ith subinterval. I'm just going to call this x star. That's what they should have called it. So number xi is arbitrarily chosen in the ith subinterval. So xi star is in what we would normally call xi minus 1 to xi, which is the ith subinterval. And let's look at what these things are. So xi minus 1 is going to be x0 plus I minus 1 times delta x. And what is that? What is delta x? We haven't even figured that out. Delta x is b minus a over n. So why did I underline that? B is 5 and a is 0, so this is 5 over n. And what is x0? x0 is the same thing as a, so it's 0. So this is equal to I minus 1 times 5 over n. And xi is equal to I times 5 over n. So what we know is that xi star is in there. Now there's a theorem in the book, not a proof, but there is a statement of the theorem in the book. You know that the definition of the definite integral doesn't depend on which element in the subinterval you pick, right? This whole thing, by the way, is just equal to the integral from 0 to 5 of 6x plus 3. Is that right? Over 5. I believe that's right. And so this thing is defined to be a certain Riemann sum, and there's the theorem and a sketch of an argument in the book that says it doesn't matter which element you take in the subinterval to be xi star. So instead of using xi star, I'm just going to use xi because the theorem in the book says it amounts to the same thing. Okay, so that was just a long-winded way of saying that I'm going to forget about the statement that it was an arbitrary element, and I'm just going to use xi. So the limit is the same. The limit is, n goes to infinity of 1 over n, the sum, 6xi plus 3. But now this xi that we're using is I times 5 over n. So this is the limit as n goes to infinity of 1 over n is the sum of 6 times 5i over n plus 3, which is equal to, I don't guess you want to just finish it off for me, do you? It's a lot of writing. And if you don't know me by now, you will never, never, never know me. Which is to say that if you still need my help on problem number 6 to do this, you should probably turn off the video and practice this a few times because you're not learning anything. You have to do it yourself. 6 times 5 is 30. Oh no. Okay, so you've got 30 over n. Now you've got an I. And this thing is just added to itself n times, gives you 3n. Here you use the formula. So I'm going to quit because I'm getting tired, but I will get rid of the sigma for you and let you do the rest. 1 over n times 30 over n. And this, of course, becomes n times n plus 1 over 2. And you've got oh, look, I made a mistake with my brackets here. So this 1 over n is going to hit everything. And you've got a plus 3n here. So go to it. And what should you get? On the bottom here, you're going to have, everything's going to be plus this 3. And you're going to have 30 on top and 2 on the bottom. So it's going to be 15 plus 3 is 18. Correct, Amundo. All right. On a sketch of y equals e to the x, represent the left Riemann sum with n equals 2, approximating blah, blah, blah. Write out the terms of the sum, but do not evaluate it. So n is equal to 2. So the things that we need to know are, of course, delta x, which is going to be 4 minus 3 over 2, because n is equal to 2, which is 1/2. And what is x1? It's going to be a left Riemann sum, so we need x0 and x1. So x0 is just a, which in this case is 3. And x1 is going to be a plus delta x, which is 3 plus 1/2. Which is 7 over 2. And great. So what is f of these things? F of x1, the function here is e to the x, so this is going to be e to the 7/2, for example. All right, so we're good to go. So the first one is going to be 1/2 times e to the, need some parentheses here, x0, which is 3. I'll just write 3. This one is going to be 1/2 times e to the 7/2. And here parentheses are important. All right, so now it wants you to do the right Riemann sum. You can just reuse this one. Reduce, reuse, recycle. So this is just the 1th entry in the sum. And now you need to do 1/2 times e to the b. And what is b? b is 4. Which sum is an overestimate? I don't know. How could you answer that question? You could answer this question by drawing a sketch of e to the x. And e to the x looks like this. And that's a terrible picture. Maybe I can use some aids here to steady my palsied hand. Here's a y-axis, here's an x-axis. And we go like, oops, I forgot to turn off the straight edge. Okay, so we're drawing some rectangles. Here's A, let's say, and here's B. We're just drawing 2 rectangles. So because this function is increasing, if we use the right-hand rule, we get an overestimate. So the right sum is the overestimate, and for similar reasons, the left sum is going to be an underestimate. Check answers. There you go. That's why I'm the professor. Next problem. Okay. Oh, all right. So these are the questions that are so easy you don't know why anybody's asking you the question. So by the fundamental theorem of calculus part 1, this one is just x to the 4th power. If you have to read and understand the fundamental theorem of calculus part 1 to know why that's true, and so I suggest you look at it if you're confused. And this will be 243. It's going to be 3 to the 4th power. What is 3 to the 4th power? Can I write it like this? 3 to the 4th power. Okay. And why did I get that wrong? Oh, 243? I don't know. I don't know why I can't do it. Sorry. Next question. So here you have, just think of capital A as an antiderivative of f, right? And it's saying that alright, so A of x is an antiderivative of f, so it has maxima and minima where its derivative is 0. But what is its derivative? Its derivative is f, which I can only guess is the curve here. The red line must be f. So a to the x has critical points at, this is 1, 2, is that 3, 4, 4.5. So there are critical points at 1 and 4.5. And the question now is which one is a maximum and which one is a minimum. So this function is the area so far, so it has a lot of negative area accumulated at this point, so I doubt that that is the local maximum. It's probably the local minimum. So I'm going to put 1 as where the local minimum occurs. And the other one is probably a maximum because you're accumulating a lot of positive area until you get to there, and then you start to lose some. So it makes sense that that would be the maximum of the area so far function. Okay, so what happens if you plug in 1 here? You get the integral from 1 to 1, and there's a theorem in the book that says that that is 0. What a weird suggestion. Or it might be that crazy number. And now what is this? This is tan of pi over 3. Good lord. I don't know what tan of pi over 3 is. How do you figure these things out? You've got sine x and cosine x. And there's an easy way to do this. What is it? You put down the standard angles here. 0, pi over 6, pi over 4, pi over 3, and pi over 2. And how does it go? It goes like 0 over the square root of 2. Is that right? Could that possibly be right? 1 over the... Yeah, this is it. Sweet regularity. And this one is 3 over the square root of 2, and this one is... Can that be right? Maybe it's just over 2. Oh yeah, I think it is just over 2, isn't it? No, that's not right. What is going on here? There's some rule. I can't remember it. This is shameful. Sorry, I haven't taught this in a few years. Is this the one that's 1/2? I'm pretty sure this is square root of 2. Oh, that's the way it goes. So this is the square root of 0 over 2. This is the square root of 1 over 2. And this is the square root of 3 over 2. And this is the square root of 4 over 2. Okay, alright, so that makes sense. And now cosine is just the same list in reverse order. Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2. So the one that we care about is this one. So tangent is going to be the ratio of these, and the ratio of those is just the square root of 3. So this is square root. I like the way it preloads it with all kinds of crazy random answers. Square root of 3. I hope we're almost done. At what value of t does the local max of f of t occur? So that's probably where f prime of t has a 0. And f prime of t is this crazy thing inside there. So, you know, f prime of t is equal to t squared plus 8t plus 12 over 1 plus cosine squared of t. And so at what value does it have a local max? We'll just, we've taken the derivative, and now we set the derivative equal to 0 and solve. This thing in the denominator here can never harm us because it can't be negative because of the square. So the real question is, when is it true that t squared plus 8t plus 12 is equal to 0? Now, does it factor? Are there two numbers that multiply to be 12 that add to be 8? 6 and 2. So this is t plus 6 times t plus 2 equals 0. So here we've got one possibility is t equals negative 6. And another possibility is t equals negative 2. This integral starts at 0, but I'm going to ignore that because, you know, it formally makes sense for these to be small on top. And you could just try them. Could do the second derivative test. But I'm feeling lazy. I get infinitely many chances, so I'm just going to guess. If you want to prove it, do the second derivative test. I happen to get lucky. It could have been negative 2. Let's go to the next one. All right. Second derivative. So the first derivative just comes from the fundamental theorem of calculus. It is, of course, x cubed plus 2x squared plus 2. So the second derivative must be 3x squared plus 4x, which is the answer. 3 times x squared plus 4 times x. Oh no, this is that hard kind. You have to break it into two parts. So it's equal to the integral from 0 to x to the 4th t cubed dt minus the integral from 0 to x of t cubed dt. That's what f of x is equal to. So all of this is equal to f of x. And now if I want to find the derivative, I take the derivative of each part, and so the first part is going to be x to the fourth cubed times the derivative of x to the fourth, which is 4 times x cubed, minus the derivative of this thing is just t cubed, or sorry, x cubed. All right, I really hope this is the last question. We've got x to the 12th power, and just in case it's not smart enough to realize those go together, we'll put in parentheses. It's 4 times x cubed minus x cubed, which is correct, of course, because I'm infallible. Use part 1 of the fundamental theorem of calculus to find the derivative. So there's a theorem that says we can reverse the limits if we make it negative, so that's what we do. T to the fourth dt, and so the derivative is just the stuff right there with and respect the negative sign. So it's, can you just not give me these insane rando suggestions, times sine of x to the fourth, and that's all. And if you're thinking, I don't understand, maybe you should read the book. And I'm sorry you were too dumb to do your homework, and you're welcome for doing it for you.